Welcome to the live stream today, everybody. I'm very happy and honored to have this live stream. We are going to be talking about and evaluating NVIDIA Robot. This is our robot office hours. We are not only honored to have some colleagues from NVIDIA here, but double honored to have actually some very special guests from Hugging Face and LeRobot. We've got, we're going to do a quick roundtable now. We'll go around, but this session is going to bring together the NVIDIA and LeRobot teams for a very focused robotics office hours on using the latest LeRobot release to evaluate and deploy GR00T N1.5 after training. It's going to highlight practical real-world deployment examples and is relevant to anyone working on autonomous robots or embodied agents at any stage. It's a direct line to the people and the community driving current robotics development. We encourage everybody watching to post your comments and questions in the chat. Let us know where you're watching from. We're going to try to take breaks throughout the live stream and take some of those questions and comments. We've got such an action-packed show today, we're not even going to cover news at the beginning. We'll cover some general news at the end of the live stream. So hang out till the end. We'll cover some slides. And as a very special treat, our producer and the better half of the community team, Amelia, will be jumping us on camera for that news stream. So you definitely want to hang out for that. But let's go around and let's introduce our very special guest, starting with my colleague from NVIDIA. Kartik, thank you so much for joining us today.
Thank you so much for having me. And it's a pleasure to be back on the live stream. I was there for a few months back, and now with the amazing team with the Hugging Face. So hello everyone. I'm Kartik Sachdev, Solution Architect, Robotics and AI, based in Munich. I've been helping partners and our customers on the robotic stacks that we have from NVIDIA. So like from a broader perspective. And in this work, we collaborated with the Hugging Face team to get a GR00T model into the LIBERO repository so that the developers and the bigger ecosystem can use GR00T along with the greatest features that we have with the new release. So really excited for the work and share with you what we have done and how the community can use it the best.
Amazing. Well, so glad to have you here. Lior, why don't you tell us what you're doing in the dark over there? And
yes. So first of all, thank you for having me. Exciting to be on the live stream again. I was your guest, I think it was over a year ago.
Yeah.
So yes, great pleasure. So I'm Lior. I'm Developer Relations Manager here in NVIDIA. Which is basically somebody that takes care of the ecosystem and our partners. My role specifically revolves robotics, and this is my relationship with Hugging Face and LeRobot. And you know, I'm super excited for this collaboration. I think the team here did a fantastic job that we're going to show soon, and going to basically make adoption of VLAs far more accessible than it is until now. And yes,
it's going to be exciting, and we're very excited. I got a sneak peek during rehearsal. You guys are in for a nice treat. Speaking of Hugging Face and awesome partners, Michelle, thank you so much for joining us today. It's great to have you. Oh, can't hear you, Mike, right now. So let me see if you can fix that setting in the gear. If that doesn't work, you can actually exit the live stream and come right back, and we'll try and we'll come back to him. Okay, so let's go to my colleague Yuleng. Thank you for joining us. You're in Singapore right now, right?
Yes. Hi team. Yeah, I am Yu Liang from the Gear team in NVIDIA research specifically. So yeah, I'm very happy to be back. Currently, located in a very odd time zone in Singapore, so it's quite dark out there. But it's okay. Yeah, I'm happy to join my coworkers, my colleague here, and also the Hugging Face team on sharing some great updates on GR00T, specifically on LeRobot. Yeah. So I think it's a very important work from NVIDIA side to contribute back towards open source. A lot of interesting research has been done on the VLM side, also on the VLA side, and how can we contribute towards open source and make sure that all this research can go into having more community support and also more community adoption. Specifically with Hugging Face LeRobot. Yeah, that would be exciting. Yeah.
Well, awesome. Well, very glad to have you here, and thanks for joining at this hour. Let's see if Hugging Face. Let me see if Steven's here. We'll see if his mic is working. Steven, how are you doing?
Hello,
Oh,
everyone.
there you go. Okay, perfect.
Very,
Well,
very
we're
happy to be here alongside you. I'm Steven Palma. I'm a robotics AI engineer here at Hugging Face. Um, I'm one of the core engineers behind the robot, and today I joined the call alongside Michelle on behalf of the entire the robot team to show you guys a little bit our exciting collaboration with NVIDIA and all the exciting developments that we're currently doing
we
in robotics.
very, very honored to have you here. And as everyone can see, he is actually calling in right now from the Hugging Face office in Paris with a nice logo. That is not a AI background. That's the real thing. So super glad to have you here. I think you have a presentation to share, so feel free to share your screen whenever you're ready, and then I'll pop it up to the rest of the viewers. I think your colleague will come back in a minute. We'll try to get his microphone. Oh,
I
he's
see
here.
Michelle. I see
think I'm
Michelle.
here,
I
but
just
can
don't
you
know if
hear
you
me?
can hear.
Oh, let's bring you up. Okay. Oh, there you are. Yeah. Sorry, you're right below me. Jeez.
No
Okay.
worries, no worries. Sorry about that technical issue. Yeah, I just want to say, well, I mean, Steven said it perfectly. I'm also like a research engineer at Hugging Face. We're also the part of the team behind LeRobot. We're very happy to be here. It's a first time for us, but hopefully it's a start of a big collaboration in terms of all topics related to robot learning and foundation models. I will let Steven talk more about what LeRobot is about, and we can discuss more details later.
Fantastic. Well, thank
Yeah.
you so much. Okay, so Steven, so you've got a presentation?
Awesome. Yeah, I'm gonna go ahead and share it with you guys.
Okay, cool.
Feel free to interrupt. I'm gonna try to keep it brief because I'm very excited to hear about all the experts here in the room. So I'm just gonna rush through the presentation so we can maybe discuss even more together
Don't be too
the
quick.
topics.
The depth is great.
Yeah, well, we talked a little bit before, so I encourage everyone on the panel to interrupt each other so we can get a nice conversation going. Steven will not be able to see his screen, so we are going to, I can see. Okay, Steven, so just so you know, we are seeing your screen right now.
Awesome. Can you see me also going through the slides?
Yep, it looks perfect.
Awesome. That's great. So yeah, I'm just gonna go ahead and start. So as I said in the introduction, well, we're from Hugging Face. So it'll be a little bit unfair not to present first what Hugging Face is. I'm gonna try to keep it brief as well, but essentially Hugging Face is this platform where machine learning community or machine learning community collaborates on models, datasets, and applications, right? It is essentially the platform that, as an AI builder, you should be using pretty much every day, right? Because it offers a lot of tooling and a lot of benefits for your workflow. Why is that? Well, essentially, the Hugging Face Hub allows you to collaborate in terms of data sets, models, and spaces. Spaces being essentially just apps, machine learning apps in the web that you can easily collaborate with the rest of the community, right? And data sets, models were essentially the core components of the AI revolution that we're seeing nowadays. So this is essentially what we do here in Hugging Face. But today, we're here to talk specifically about a vertical that we have related to robotics, right? And it all comes down to, we essentially ask this question about how can we make robotic learning accessible to everyone? And by robotic learning, I mean, nowadays we have all this AI revolution going on, right? AI is impacting our lives in different ways. And we also see this AI revolution happening currently in robotics, right? So essentially, every day that we go in social media, we see a new robot doing some new tasks that we previously thought it was very hard to accomplish from a technical perspective, right? And it's because there are a lot of breakthroughs, right, in the field, in the community. So us in Hugging Face, we thought, well, wouldn't it be cool if we provide pretty much everyone out there, all the developers, all the users, all the hobbyists, with the right tools in order to essentially profit or not profit, just benefit from this robotic learning revolution, right? And this is how the robot came to life. Essentially, the robot is an open source project that is making AI for robotics more accessible with end-to-end learning. And I like very much here the word accessible because I like to think about it in threefolded. The first one is it is an open source project, right? So then that means that everyone can collaborate, everyone can exploit the project, everyone can just take a look on what is going on, the development and so on. It's completely transparent in that sense. The second thing, it is accessible also because it is low cost. And by low cost, I mean, essentially we're dealing here with robotics, right? And robotics, you need hardware, right? You need to move things around. And it is not very accessible if your hardware is very expensive, right? And very limited to maybe top-notch labs, right? So essentially, in the robot is a project that is accessible also because the hardware that you need is very low cost. And there, the third part in which it is accessible, it is, well, essentially, it is open source, right? As I mentioned before, so it is free to use, right? Everyone is encouraged to give it a try. Now, I'm gonna do maybe a brief introduction of what the robot is, right, and why it has become so popular in this year and a half, because it is a very young project overall. But essentially, it is because the robot offers the developer this end-to-end experience in which they can use all these tools to develop an intuition of how these robotic learning policies and models actually work, right? So we have things, so we have here a little diagram, right? On the left, we have the robots. In the middle, we have other components of the software library, which is related to the teleoperation, the control, the dataset recording, the inference, and on the right side, we have the policy training, which we're gonna go in more detail after that, after this presentation. But what I also wanted to say is, well, the robot essentially, not, it is not only accessible in terms of affordability and open source and so on, but it's also very collaborative because it is a community-driven project essentially. Well, here on Hugging Face, we take very much ownership of the health of the project and so on, but everyone is encouraged to participate. But it also offers the developer or the hobbyist out there the opportunity to have a first-hand experience with the latest state-of-the-art models, right? And this is what I like to call the project being contemporary, right? It's not only easy to use, open source, but it's also very relevant to what we're seeing nowadays with this AI revolution for physical AI and robotics. So yeah, let's see. The robot, as I said before, we have the robots. That's great. We're gonna need some hardware to move, right, in order to fully benefit from all these models and policies. Some examples that we have over here that we can see in the slides are the SO100, which has become very popular. We also have a mobile BEOS, which we like to call the Kiwi, right? All these are open source as well. You can build it by your own. I think the SO100 cost is around $200 for the pair of arms. So it's very accessible in that sense, right? And this hardware serves as a vehicle for the developer, for the user to build intuition about the policies, right, and the models. So we have in here, some little videos. Cool. Here is the Kiwi just moving around the office, right? And this is things that people can use to experiment and bring their creativity spirit to the project. We also support robots in simulation, right? We're gonna talk more about this maybe by the end of this presentation, but yeah, this is essentially just telling you guys the robot can also support to a certain degree robots in simulation, which is great because that even means that you don't need hardware to test it out. And then going back to the beginning, to the diagram that I showed at the beginning, right? We said that the robot is this end-to-end software library that walks you through the entire pipeline that you need in order to for you to experiment with all the models and policies. And one of them, of course, is control and teleoperation, right? If you have your robot, now you have to move it, right? And if you need some other tool in order to accomplish that, then it's going to get complicated for the user. So in the robot, we also offer you the tools to move the robot, right, and to operate it. In here, we just had the example of the GR00T, right? But of course, it could be, as we have seen in the other videos, the SO100, the Kiwi, or any other hardware device that you might have out there. Awesome. Then we also have, again, part of this end-to-end pipeline, we also have the tools that allow the users to record their own data sets, right? We have learned so far in this AI revolution that data is one of the core components of it, right? So we gotta go, and if we wanna make some physical AI experiments, we're gonna have to collect first data, right? We need to recorded with our embodiment, and we need to process the data and so on. So in LeRobot, we also offer, or we also have available these tools such that the user only needs to use LeRobot in order to walk through this entire pipeline, right? And here we have some examples of adoption of the LeRobot dataset format, and some tooling around the datasets that maybe we can discuss later on. But essentially, these are visualizer of people just teleoperating their robot, recording the data, and now once we have the data, well, what do we do with it, right? And this is the next part of this end-to-end pipeline that I was talking about at the beginning, in which, cool, now this is the moment in which we're essentially experimenting truly with all these models, right? Specifically for robotics. And here, why? Because in the robot, we do support different or plenty of different policies, in which you can take the data that you just recorded and then train your model, right? By training, I mean, well, you gotta select first what's the model that you're gonna train this data with, right? And the challenge I find is that nowadays, if you want to go and you see in social media all these robots doing crazy stuff and so on, but you want to experiment with them, right? You want to build some intuition about how these work, what are the important components of it, right, and so on. But there's no specific platform in which you can do all that, right? And the robot is kind of like filling this gap that we found in the community, in which people were very much eager to try. In this case, for example, in the slides that we're currently seeing, ACT, which was one of the first policies that we supported in the robot, because, well, the policies turns out to be very capable. And this was one of the first policies that we supported, but we eventually continue experimenting internally with, in this case, with VLAs. This small VLA, this is essentially an in-house VLA that we design, train, here at Hugging Face, also not only to experiment ourselves, but also to put it available out there to the community. But most exciting, which is pretty much the reason of this collaboration with NVIDIA and also this call, is that we recently integrated GR00T into the robot, such that people can natively use GR00T model in the robot, right? But overall, in the big picture, essentially what I'm trying to say is that the robot offers you all this catalog of models that you can pick depending on your application or depending on your objective of learning, and just do the end-to-end from teleoperating the robot, recording the data, training your model, and the final step will be essentially running the inference, right, and evaluating your model performance, right? So essentially, all these tools are the reason why the robot has become so successful over the past years, over the past months, essentially, because it fills a gap. It fills a gap of the developer wanting to experiment with robotics. Well, suddenly we have this bundle package in which they can deal with all these little steps, right? From getting the hardware, implemented their own hardware, teleoperating, recording the data set, training the model with different parameters or with different. I'm guessing we're gonna also talk a little bit more about how we fine-tune VLAs, specifically GR00T, right? And then how, once your model is cooked, how can you evaluate it, right? Which is also a crucial component in the robot that we are currently working on, which is providing all these tools to developers to not only record, train, and run the inference of your model, but also evaluate it, right? Which is, it proves to be very, very useful for research, for hobbyists, for even companies out there that decided to use the robot as a core component in their business model, or not in the business model, in their technical architecture. So we're very happy to see the adoption that the robot has had, especially because, well, it is an open source initiative here at Hugging Face, and we're very much excited about all the features that we're gonna collaborate, that we're gonna develop in the future, and all the future collaborations that we might have with NVIDIA, of course, but also with other research labs out there. In here, for example, in the slides, we're seeing one of the evaluation benchmarks that we currently support in the robot, which is LIBERO, which is essentially, we run this simulation multiple times with the model that we just trained, and then at the end of the day or at the end of the test, we get a success rate, right? And this give us or provides the user with a lot of intuition about what are the important components of their pipeline, right? Is it maybe improving my data collection? Is it maybe improving my training parameters? Is it maybe hardware related issues, right? We have here in the office, this is the thing with robotics. It is tricky, right? And there are plenty of sources for issues, and having a clear way to evaluate your results it has been proven to be very crucial in all these AI revolution. So yeah, I just wanted to make maybe some final words about what makes the robot special. And I think, sure, from a technical perspective, it is amazing, right? Because it allows us to do all these things in an easy way, in an accessible way. Um, but definitely, one of the things that we have enjoyed the most is essentially the community, right? Not so long ago, we launched this global hackathon in which we encourage developers all around the world to just come out with different robotics demos, right? Of course, using the robot and doing their own experiments, and we were very much surprised by the adoption, by the enthusiasm that everyone brought to the table, and we definitely identify the community, of course, as being a core component in LeRobot, right? Which is resonates, or yeah, it resonates with Hugging Face mission, right, of being very open, being very collaborative, of being for AI developers of today's, but also in the future. Right? So yeah, and here we only have some of the experiments that we're currently doing in the office, in which we have different type of robots. We're running different type of experiments for data collection, training, inference, and all this is possible thanks to the robot, because the robot again offers you with all these tools in a centralized manner, such that even if you're new to robotics, you can just jump ahead, do a couple of pip install, and then you're ready to go, right? Awesome. Some other videos, exciting videos about what's coming on. We have also been experimenting with humanoids, and the good thing is that I know all these videos I have been showing so far are internal videos in the sense of the things that we're currently experimenting here in the office. But the idea is that everyone out there can essentially, they're free to experiment with their own hardware, with their own policies, with their own data recording pipelines, and all this is possible thanks to the robot. Close. Yeah. So how to get started? As I have been saying so far, it is very easy to use, which is part of the accessibility of the robot. Just an easy pip install the robot, and then you're good to go, which is incredibly useful if you're new to the field, especially new to robotics. You don't want to deal with all the complexity behind, I don't know, operating systems and so on. So yeah, we put a lot of effort in the robot to make it easy to use and accessible for everyone in the community. Awesome. And then just as a final word, we recently released the new version of LiveRobot, the VO4, in which we added plenty of different features, new features, very exciting features, especially for the community, internally, from a technical perspective, from the, well, actually, it was in this release in which we announced the integration of CRUD into LiveRobot. So then that means that everyone out there, they can install the robot, and then they can immediately benefit from all the incredible research, analysis, and architecture that the NVIDIA Robotics team has provided us with, which is GRID, the GRID model, which we're going to talk a little bit more later today. So feel free to check it out. I'm not going to go through all the details of the things that we included, but yeah, they have been very exciting. They have been very much welcomed by the community. So here are a couple of QR codes in case, but essentially they're just links to our GitHub repository, our X account, and then our Discord server. Maybe one of the most important things to do today will be to join our Discord server, because that's where the action is happening. This is where people share their ideas, they share their feedback, they meet other people who is also very much interested into robotics. Yeah, it is just very exciting to see such a vibrant community around open source robotics learning. So that's pretty much it. I'm gonna stop sharing my screen. Is that okay?
Of course, that is fantastic. You know, we have a lot of great comments coming in from all over the world. Actually, during your presentation, I was glued. Every slide was pretty amazing. So thank you so much, Stephen. And Michelle, I saw your name in there in that last slide on that announcement, which is pretty cool. But you know what also is pretty cool? A guest here that I totally forgot to introduce. So without further ado, I apologize, Risha. I probably forgot because he's so normal to bring on the live stream. He just blends
that's
in.
completely okay, Admiral. Hey everyone, happy to be here. I'm Rishabh. I'm tech marketing engineer at NVIDIA, mainly focusing on simulation. So end-to-end reference architectures, workflows, also working with like Arctic, Leor, and others within the broader NVIDIA robotics team. So I think I'm probably similar to most of the audience here, where I'm going to learn a lot more because like these guys are the experts here. So thank you, Stephen. The presentation was amazing too. I think we probably might be having some questions. Adma, do you want to pull up some questions, or how do you want to proceed?
Yeah, we have a few questions. And let me say, a couple big takeaways for me from watching that. Obviously, we have so many people using the SO10 and 101 ARM. I think, and you also mentioned the accessibility and community. I think that, and Hugging Face has such an amazing reputation among robotics developers in the world. I think Jensen has called it up many times in his various keynotes for good reason. Another reason why we're so thankful to have you here today. But you know, over and over again, I think the barrier is just becoming lower and lower, and accessibility is just becoming wider and wider. So we're seeing so many different types of projects within robotics, and you know, I'm a big fan of Ken over at Worker Labs, and he said recently, and he sees the future of robots. He thinks will look very much like a Star Wars type of universe, where we won't see, you know, just a humanoid doing everything. We're going to see lots of different varied types of robots, and I love seeing those kind of projects in the hackathons. All those different types of uses you see, really, really fantastic. Okay, so we got a couple of great questions here. Yes,
Edmar,
please, Lior.
before you go ahead with the question, I think I want to layer something on top of what
Please.
Stephen said, and I think that one of the I think that the highlights of what's happening with the robot is basically, I mean, unknowingly, the guys have basically established a standard in this huge zoo of research, and I think this is what drives everything, because in order to actually advance this cutting edge research, and so that everyone from all sides of the globe can enjoy the fruits of the others, a standard has to be put in place. And I think that what's happening in LeRobot is basically defining that standard in a very gently way, open source way that everyone can contribute into. And I think this is part of this magic, you know, that's happening around LeRobot.
I agree. I encourage everyone to jump on that Hugging Face Discord. I think it's a great resource. We also, in the chat, we also have a few people watching who are part of the Isaac Sim and Isaac Lab study group on the Omniverse Discord server. That happens at 12:30 p.m. Pacific every Wednesday, so you can jump onto that after this. Okay, so we do have one question here, and then we can go do some show and tell here also in a second. But question here is regarding Groot dataset and Hugging Face. Any compatibility issues right now between Groot and Hugging Face and LeRobot?
This one is for Karthik, definitely.
He's smiling. He's got a big smile, so I think he's got an answer here.
This is what we exactly solved. So you can use the LIBERO format, what is there, and as is, you can train the Groot policy with the current LIBERO format there. So there's no compatibility issues, and I think you are good to go. And yeah, so I think that would be my answer. And I was waiting for this question to come up.
That's great. Well, I think that was the first question. Actually, it's one of the only questions we've got. We have a bunch of comments, but they're all people, you know, thanking for the presentation. I think someone actually whose project was in Stephen's deck is actually watching. He's, oh my gosh, that's my project. That's so cool. You guys have such an engaged community. It's really, really awesome to see. Okay, we have another question from Tech Lover. Tech Lover on YouTube is asking, do we have the links to the robots to build them? So how do people get access to just where do you recommend people go to actually for some of the robots we're showing off here?
Yeah. Michelle, maybe you want to talk at that one.
Yeah. Can you hear me, guys? I hope.
Yes.
Yeah. So basically, everything we do is open source. So you can, for many robots, for example, like the SO100 arms and the SO101 arms, you have direct access to the meshes of these robots. So if you have a 3D printer or if you have a way to order 3D printed parts, you can just 3D print them at home, and you just need to order the motors, which are also very cheap. So at the end of the day, it will cost you around 100 euros per arm. So it's built in a style where you can DIY it, or you can. We also partner with some manufacturers in China where you can very quickly order it. In a few days, it can arrive to your home pre-assembled, basically. So, but in terms of the links to the various robots, you will find everything in our GitHub and in our docs.
Okay, we'll make sure to put that link in the chat also. And thanks to our producer, Amelia, who's handling the chat right now. We have another question coming in from LinkedIn. My question is, let me try to read this correctly. My question, there is a problem with model if there is a slight change in the environment that model behaves differently, how to optimize these data collection things. What are the best ways to recommend? Okay, there's a bunch of commas missing in this, but if everyone can get the point here, who wants to take this one?
I can maybe
How
just
about you,
start, give my opinion.
Yeah.
Yeah. It's Can you hear us? It's
yes.
Okay? Yeah. I
go
think for
ahead.
me, I mean, the question about like how to collect the data and how to optimize the behavior of the data collection, we need to keep in mind that this is also kind of like a research question by itself, basically, like what is the optimal way of collecting data and how much data do you need, and at what point are you going to basically need just a couple of trajectories from a task, and then you can train a model to generalize over that task. So at least let's say for the settings where we are just training on a single task, it would be nice to try to have a data set that is that incorporates different variations of that single task. And basically these type of models, if we're just talking about imitation learning models that just learn to clone the behavior in your data set, it's basically going to be just as good as the data is. So you're going to need to basically collect a data set that is diverse enough, but also, as we see with the bigger models that are pre-trained on a lot of data. I will let the guys maybe talk about it a little bit. This is also changing a little bit. I'll let maybe Liang talk about it more.
Oh yeah, thanks. I think Michael actually kind of like covers it pretty well. Yeah. So to add on, I think that's a limitation of the current behavior cloning or imitation learning method. So the research paradigm is about before that we might need 100 trajectories to able to complete the task, but moving forward, we are seeing like larger model or better foundation model actually makes it more data efficient. Instead of way that you, instead of needing 100 trajectories, you might need 50, and eventually you might need just 20 or 10 or even just zero shot. So I kind of being very hopeful that would be the future, about you can zero shot it by just providing it in context in the future. We are getting there, but yeah, more research needs to be done.
Very cool.
Yeah, if I may add, just a couple details in here. I think this question we can go on in this question for maybe 4 hours, right? Because it is, as Michelle said, it is truly almost a research project by its own. But yeah, I want to highlight 2 things that Michelle mentioned just as a takeaway. I believe that, for example, in imitation learning policies, well, the performance will be, or imitation learning will be as good as its demonstrations, right? So if the demonstrations, that is, if the recorded data is not doing a great job, then don't expect the policy to do a great job. Of course, we can go into details about how many episodes and how to fine tune things here and there, but this is where the part where the question might get a little bit extended. And then the second thing I believe in VLAs, I think I have realized that entropy is a big thing. Do you want to make sure that your dataset is diverse enough? Because essentially you're trying to build a model that has very good intuition about whatever is seeing, right? And in order to build that, you're going to need to feed it with a bunch of information, right? Which might have, and by entropy, I mean different things in the scene, more diversity in the dataset, essentially. So these are maybe 2 takeaways that will personally follow to improve, right, the performance based on the data collection experiments.
Okay, now on a related note, we got a question here from Pistorio on YouTube. What compute setup?
I think for that we can show in the hands-on soon. Like
Okay.
what is the computer we're using?
Great. Yeah, I think you're going to leverage Brev, if I recall, right?
Yeah. We're going to show it use Brev.
Awesome. Okay, great. So we're going to go with that in a few minutes. Another question came in from YouTube. I'm not sure if anyone on this panel happens to know. Obviously, we mentioned that you can download and 3D print or work with a local, maybe 3D printer to print these robots. But does anyone know if the ARM is available for purchase in India? I'm sure it is.
I believe it is available. The major bottleneck being the motors. I think you can still get the motors. They just happen to be way more expensive than the price listed in the link shared below.
I see. And, it sounds like a great place to talk about that kind of discussion would be the Hugging Face Discord, where I'm sure there's probably other users in India who are chatting exactly that. So head over there. We'll put the link for that in the chat. Okay, I think that's the last question we've got right now. A lot of great comments, though. Does anyone? Okay, so Lior, did you want to try to do the honors here and to see if we can go through? Does anyone else want to bring up any other questions or comments from the panel before we move on?
I just noticed. Yeah, thanks, Stephen, for the presentation. I noticed you guys have a lot of cool robots there. Like open arms. Are those open arms? Just quick questions. Yeah, and also G1. Okay.
Yep.
Very nice. Very nice. Yeah.
Seems like a very fun office to work at. I wouldn't mind going there every day. Lots of action.
Yeah. Yeah, it's similar to Gear. We have a lot of different kind of robots. It's also great to see Hugging Face also get different kind of robots to really test out the model in different embodiments.
Yeah, and hopefully maybe Lai will also show our new features related to simulation and evaluation.
Ooh.
Maybe by the end of the stream.
Okay, cool.
Let me share the screen. Let me share the screen.
And also, maybe you can also build a little bit of context related to what you're going to show, right? Which is essentially how to fine-tune
yes.
in the robot. That's great.
Yes. So Edmar, let me know. I mean, I'm ready.
We're all looking at it now.
Okay, perfect. So I guess, and I think this maybe someone can paste this link into the chat so that everyone can get and see it. So this is basically the blog post that we've shared after we finished the integration, and I think I can go fairly quick over this process so that everyone can see how we do it. Obviously, I'm not going to read it line by line, but essentially. This process go through obviously the motivation, and that was already discussed before. So I'm just gonna get right through it, and how basically someone can start using the robot and Groot today. So the installation and the setup that I will show has already been done, obviously to save time, but the installation is fairly simple, right? And it's all in this snippet. But first, compute, right? In order to fine-tune a model, to fine-tune Groot, you need compute. So,
Stephen, really sorry to interrupt, Stephen. If it's possible, I know some users might have different size monitors. Can you increase the size of the?
Yes.
Yeah. Oh,
is it better?
Perfect. Man. Yeah, very.
I'm old too, man. I
yeah,
know.
perfect.
So, yeah. So, okay. So not everyone has access to compute. I mean, when we fine-tuned the model and we tried it, we were using H100 GPUs, right? And it's considered to be very, very inaccessible. But recently, or not recently, we've released a service called Brev, and Brev basically is a service that I already have open here, and obviously due to the live thing I've got logged out, but here I'm going to be logged in back again. Is a service that we're offering for everyone to come in and basically grab almost every kind of NVIDIA GPU, obviously that has its own cost, but the cost is not dramatic if you want to fine-tune a model such as Groot N1.5. So I'm going to just go really quickly. I was in GPUs, right? This is the Brev console, and obviously the link will also be in the chat. Creating a new instance, and in our case, we're going for the H100, right? The version that is right now online on the Hugging Face GitHub I'm not sure we're already supporting Blackwell. We're supporting Blackwell internally, but I'm not sure it's already available. Kartik, you can comment on that later. Anyway, and the simplicity of getting a system is like that. You just select the GPU type flavor that you want, and you can select the number of GPUs that you want. And in my case, I have selected 4, and we've tested it also with 8 GPUs. You can also do it with 1, right? It's just a matter of time and how long would it take to train the model. But with 4 GPUs, you're looking at several hours, okay, to complete a run of about 40,000 steps, which is enough to get to the benchmarks that we've reached. Okay, so assuming you selected 4 GPUs of H100, you just click that, give it a nice name, and deploy that. And at this point, you're gonna be inside your, you're gonna get access to your Brev instance. And I think I need to drop my share. Edmure, can you cut my share screen so that I can switch to the console?
Done.
Done. Perfect. So give me a moment.
And thanks for we got some good questions and comments. Amelia is
In the
pasting the links in
meantime,
the chat.
maybe I can add. Oh,
no, go ahead.
Go ahead.
Yeah, Steven.
No, in the meantime, maybe I can add that here at Hugging Face, we were experimenting with Grid. We actually used Brev in order to train, test it, fine tune it, and so on, which is what Lyra is currently showing.
Yes, and we also had a comment here from LinkedIn from a user who actually leveraged some Brev credits that we gave away on last week's live stream. So here's a little hint to everybody watching. You can still catch that live stream up on YouTube if you want to get the link to those credits. I think there's a few hours in there, so it should be good to cover you for a little bit. Lior, I can share whenever you're ready again.
Yeah, give me a second.
Yep,
because
take your time.
I want to have a dual setup with the.
No rush. Take your time.
Yeah, while Lior is setting up the his system, so I just wanted to highlight the fact that we supported this LIBERO hackathon which happened in Munich, and it was like super awesome. Like the craze for roboticist community coming together. I mean, we saw the participants right after their bachelor's or during their bachelor's to the PhD students. So it was like really amazing, and also like working professionals. So this really shows that the extent and the impact that LIBERO is having on the ecosystem, and it's not only the developers but also like the working professionals. And so I think just wanted to highlight because I couldn't get that time back then, but yeah, so it's a great work these guys are doing.
It's fantastic. I think hackathons are also just an amazing thing in general. So keep your eyes open for some other ones. I know Revel just announced one for Isaac Sim and Isaac Lab. Okay, cool.
Okay, so I'm ready, Edmure,
all right,
if you want.
all right, here we go.
Yeah.
It's now we can all see it. I'm gonna make it a little
You're
bigger.
supposed to see like a split screen situation going on,
perfect.
Right?
Yep.
Okay, perfect. So I mean, on the left side you see my console, and on the right we're back on the blog, right? Just after the installation process. So I wanted to show you, I mean, how easy is Brev. If I just go now, I'm on my own personal station, right? And like assuming it doesn't have any GPU, though it does, but assuming it's not, and I can just pick up the instance that I want to log into, and I'm going Brev shell, and that will immediately connect me to that session where I can start and work and leverage many GPUs basically. So just to confirm, now we're inside, right, the remote machine, so we can see that we can have access to 4 H100 GPUs, and what was that, about $9 an hour? So I mean, several hours. It's not that expensive. I think it's within reach to everyone to kind of take a policy and fine tune it. And as I said, I've already gone through the installation, so I'm just going to activate the Conda environment. And once I'm inside, I think we can. I mean, there's no any setup that needs to happen other than just starting and running that policy. But I'm not going to pick that simple one. I'm going to show you how we leverage multiple GPUs, right? So this is another great thing about LeRobot. They have this accelerate library that can leverage multi GPUs very easily. So let's just copy this command, and this command already sets to take a data set that LeRobot were generous to give to the community so that we can, everyone can try that. But you know what? Actually thinking, because I also want to show simulation, let me not start this run. Let's start the one with a more complicated command, right? And if somebody from the team want to go over and kind of unpack what's happening here on the screen, I think now is the great time while I kind of flush out those arguments. Stephen, Karthik, Michelle, go ahead.
Yeah, I think this is the command with Libro, right? With the where we train for the Libro task. This
Yeah, I
is
mean, in terms of
exactly.
like the step size and their effect and the batch size and these kind of things, right? That maybe not everyone are familiar with and their effect.
Mhm. Yeah.
Yeah,
So
we can discuss if
my
you want maybe just well, first the point that if you see like in the start of the command, you see the keywords accelerate and launch and multi GPU. The main point is that here we're going to take advantage of all the GPUs that we have on this Brev instance. So like Lior said, you have 4 GPUs, so you're going to use the 4 GPUs, which basically is going to make your training 4 times faster, even maybe a bit more. You guys want to also talk about maybe like the step, so then you have like the arguments, so you run the robot train command, and then you have basically all the arguments that are related to the training itself. So what is the batch size I'm using, so within one forward pass, basically how many samples of data I'm using, how many steps do I want to do the training for. You have some logging arguments basically to determine how often you will see like what is your loss, how about monitoring basically the training process. And you also have like an important detail when it comes to the policy. As you saw, you have this repo ID argument, and you have obviously the policy type is root, but you have this argument repo ID and push to hub. This also is very powerful related to the Hugging Face hub itself, basically, where you can upload the models that you are training directly on Hugging Face. So, for example, the NVIDIA guys have open sourced the GR00T checkpoints that they have used. So you can go, if you go to the NVIDIA space to GR00T, you will find the checkpoint that they have actually trained, and then they have open sourced it, so you can actually reproduce or replay the same model that the NVIDIA guys use, just because it's available on the Hugging Face hub. And the same thing goes for LeRobot.
Michelle, while you talk, I'm going to just hit enter and run this command, and you can go on and talk.
Sure.
Yeah.
Sure. Go ahead. Yeah, so this is like an important detail where basically you can just fetch and download basically different type of models. You have the option on the hub, obviously, to make your repositories private, but you will see like many open models out there of people that have trained on tons of data, especially, for example, like I mentioned, the GR00T one, where you can just download it very easily. And it's quite an important step in the paradigm of robotics, where you can kind of, instead of just reading about the results of certain models, about what they advertise, you can actually just download the model yourself and try it yourself. And this was also very important for us to make sure that the implementation and the port was faithful to the original implementation. And here you will see now the verbose, the commands of basically what is your loss, what is your learning rate, all the state of your training.
Yeah, I can also add a couple of words in here, just to get on maybe an eagle view for less experienced viewers that we might have in the live stream. So essentially what we've just seen is 3 things happening. The first one is Brev. Brev allows you to get access to GPUs, right? You need GPUs because you want to train your model. Then the second thing that is happening is LeRobot. And in LeRobot, you have all the tools to train, evaluate, choose your policy, and so on. And then the third thing is, as part of LiveRobot, we of course have a tight integration with the Hugging Face hub, which is what Michelle was mentioning before. Once you have trained your model, it will be immediately available for distribution out there, right? It will be already in Hugging Face. You can share it with your friends. You can reproduce
I'm
your
showing
evaluation
it
results.
while you're talking. I'm like assuming this train will be finished. This is like the policy that is already up over on Hugging Face and can be used for evaluation.
Exactly. And all these things are possible thanks to the robot. Actually, Leo just showed right before a dashboard in which we have the statistics of the training, right? All these things are already natively integrated in the robot, right? So you as a developer, you run a couple of commands and suddenly you have the policy of your choice being trained. You have all the instrument to monitor it, right? Because this usually takes some hours. Brev allows you to get access to very high-end capable GPUs such that you don't have to wait 10 hours, right? You just have to wait 1 hour, which is very useful when you're doing these developing cycles. And maybe Leo will also show, okay, once we train the policy, how can we evaluate it, right? And what are the tools that the robot uses to enhance this process for developers?
Exactly, and this is what I'm going to show right now. Assuming I'll remember. So you know what? I'll just make my life easier. Let me go up here to the top. No, that won't help. So let's just try this. So now I started a new terminal and I'm back on my own machine for the evaluation process, right? So I'm going to do conda activate. I think it is. Sorry, I have many different environments going on. But anyway, so I'm back here in the blog that we've posted, and we want to evaluate the policy, right? So assuming that thing is gonna be over in a few hours, it's gonna get uploaded to the hub here, and we want to evaluate. So specifically, the policy that I'm gonna show you is the LIBERO object one. Okay, and you can also see our score because it's a live stream and you want to look good, so I'm not going to show you something that is less than 99% success, right? So this is the checkpoint that I'm using to show. Okay, and the way I'm going to do it is, again, I'm inside the LiRobot virtual environment and I'm taking this command, the LiRobot eval. Okay, but I do want to change it a little bit because this one has been written for the LIBERO 10. So this one is going to be LIBERO Go object, sorry. Okay. And
maybe in the meantime, while you crack out the command, I can also say some more words. And the thing is that in here we're essentially benefiting from the fact that the robot can help you evaluate your already trained model. In this case, we're gonna use LIBERO, which is one of many benchmarks available out there for the community. But you can also use, for example, how's the other one called? I just forgot. Multi-world? No.
MetaWorld? No.
MetaWorld. MetaWorld.
No, I'm not sure. Anyway, maybe
MetaWorld. Yes.
MetaWorld.
MetaWorld. Yeah. Thank you.
MetaWorld.
Yeah, so you can use LIBERO, you can use MetaWorld. We recently made it possible for people to come out with their own benchmarks and then just natively plug it into the robot so they can share it with the community out there. And this is very important because going back to the beginning, I think Nair mentioned it. Currently, we have all these different labs doing their own research individually, right? And when they come out and they want to share the results, well, we're missing this common framework in which we can all collaborate together, right? So ideally, if a very capable lab comes out with a new model and I want to evaluate it, then I should be able to do it without having to have their own specific setup, hardware included, software included, and benchmarking included, right? So the robot essentially is giving you all these tools to collaborate in this robotics learning revolution that we're having. And here,
I know what happened. I made a
out.
mistake. I told you that I have too many environments and I was in the wrong one. So this is the environment I needed.
The pictures.
The what? It didn't. Now we're gonna see it. Give it a second. It's excited as well.
That's the beauty of a live stream.
Yeah. I know. Okay, so we're gonna see it here. Hopefully. No, not like that.
Steven, one quick question. Are you guys planning to integrate simpler AMP to the benchmark soon?
We're really much interested in adding as many benchmark evaluations that we have out there.
Okay.
There
It's
are
always the
two ways of doing that.
bandwidth. Yeah.
Yeah, there are two ways of doing that. First one is us integrated natively into the robot code base. But the second thing, which I find it more interesting, which is a little bit more sustainable moving towards the future, is that essentially any community member has now, or just the robot user, I meant, and a Hugging Face Hub user, can now upload their own simulation environment and benchmark to the hub and just plug it into the robot without us having to maintain the source code essentially. So, but yeah, moving forward, I think this is one of the fields where the robot can make very much of an impact, and we can see it over here. Very very exciting thing happening in their screens.
Yeah.
Because
Yeah.
benchmarking of these models is very important, and we want to make it easy for the user to explore and to build intuition behind all of them in a really easy manner.
And I think I want to add something. Right now, what we're seeing, after all, we're NVIDIA, and we're also into simulation just a little bit. And this simulation is still not using Isaac Sim or Isaac Lab, but I want to kind of give a sneak peek to everyone that this is also coming. Not committing to any timeline at the moment, but we're building on integrating Isaac Lab as an evaluation engine also under Hugging Face and LeRobot, which is going to be very exciting.
Amazing.
Yeah. But not much more about that at the moment, I guess.
Stay tuned.
Yeah, definitely.
Yeah.
How much time more do we have? Because I can show something in Isaac Lab that I think is going to be very exciting to people.
Well, I'm not going to stop you from doing that. I'll be the last person to stop you.
Okay. So I think that can be pretty nice. So what I want to show is there's another small project that we've been up to, not exactly with the robot team, but using the SO101 arms. And this is just the foundation of what's about to come from this collaboration. And this is basically having an interface to teleoperate from the SO101 arm into Isaac Lab, record a set of demonstration directly using LeRobot and the LeRobot dataset, and basically evaluating them inside Isaac Lab. Still not completely fully integrated with LeRobot, but I think it's going to be a nice sneak peek if you want.
Yeah, go ahead.
Yeah. Okay. So let's do it. So this is basically I'm inside my repo here, and I'm gonna show you a bunch of things. So you don't see it, but next to me there's an SO101 arm, and I'm going to start a recording session with it, a teleoperation recording session into the simulation. Okay. So now I'm going to start Isaac Lab. Hopefully you're going to see it coming up. And you will excuse my poor performance because the task I'm going to show is fairly hard. It's not trivial.
Leo got us, everyone. Got every one of us just hooked to the screen.
I'm on the edge of my seat right now.
Okay. Don't worry.
We're just waiting for it.
Wow,
Okay,
it's so realistic.
So this is basically the task. And wait, you know what? I'm going to also show the console here, because the console is also important. I mean, it's not just a nice game that we're playing. We're basically recording a set of demonstrations. So this utility to allow you to kind of and you will see I'm going to hit my keyboard to start a session, to start an episode basically. So now our recording is started, and sorry, I haven't trained on this for some time. And you see that the task is fairly complex because on the right-hand camera, there's no way I can complete it successfully. So I do need to see also from the left and side camera, and I'm gonna screw it up or not.
Let's go.
Impressive.
So yeah. So this is successful recording, and you can trust me that I have made a bunch of those, about 50 examples, and I was actually using the ACT model that Stephen was talking about before, and now I can show you basically an evaluation inside of the simulation of this policy. Okay, so I took 50 episodes of this task, and now you can see that the policy that was trained using these only 50 episodes is going to be evaluated in the simulator. Okay, and that's, again, it's using the LeRobot interface. We're going to also see the rerun interface to show all the observations and actions in real time. And again, the experience is really fun. So are you going to see the robot doing it on his own? It's like fully autonomous, and it's a very complicated task, as you saw.
Yeah, and then maybe there to add some detail, Leo, you just mentioned
Yeah.
that you're in here we're running ACT policy. It is great because it allows you to iterate fast and it's easy to train and so on. But this is the magic of LeRobot, right? You now, as a developer, have built some intuition around how ACT works, and now maybe you feel ready to go to GR00T, right? Which is the reason of this collaboration. Now we have it in LeRobot, and then that means that you should be able to also, thanks to LeRobot, train GR00T and then deploy GR00T, right? And
Exactly,
just a
using
developer can just
the
go
same
and pick the
data
policy
set.
that you prefer. Yep.
Exactly. So the same data set, same everything. And I mean, ACT is not performing. Maybe now I will try using small VLA. Small VLA won't work. Now I can try to do something more robust that takes more compute to train. But essentially, yes, you can see the success rate is not fantastic, right? Around 50%. And we're probably going to end on these 50%. But yeah, this is where we at the moment with that. And hopefully, in a few weeks, month, I don't know, we're going to also show this policy transferring to the real world, that though it was trained only in simulation, but still some things need to be figured out on my side. I'm going to stop the share screen for now, Edmar, if that's okay with you.
Yeah, please. Yeah, that's fantastic. A lot of cool excitement here. Look at someone's posting here. Amazing. I'm working on the same interface for my project. Is there a repo where I could see how you implemented it?
Yeah, so the repo is actually online, though it's not fully updated. And I guess I can paste the link here, but it's not going to be as updated as what I've just shared, but it will be updated soon.
That's great. Okay, so that was fantastic. We're seeing a lot of comments. We have some questions that came in a little earlier too. If we have time to go back, I'm not sure if does anyone have to leave right now. We got a couple of extra minutes. Okay, we can go forward. Okay, cool. All right. Here's a great question, I think, for some of the people who are watching this live stream in awe and really want to kind of get started on their journey. Where can we get started with robotics for someone who's totally newbie to GR00T, Isaac Sim, and Isaac Lab? From the NVIDIA side of things, there's a great learning path from DLI called Learning Path Robotics. Our producer will post the link in the chat. I think that's a great first place to go. It gives you a nice introduction to robotics. These are free self-paced classes. Do it on your own time. I would start there, but I'm sure everyone else has some other ideas for some getting started resources.
Maybe the LeRobot repository itself. Oh, then go ahead, Kartik.
No, I think LeRobot repository is is a fantastic way. And also, just adding one more point, they also released like a robot learning tutorial, which Michael was co-author, and it's very extensive. Maybe Michael can talk more about it. Just touching upon the resources that we have from NVIDIA, definitely this robot learning path is great. But also we have all our Isaac Sim, Isaac Lab, GR00T, they're all open source, so you can check it out. And also, there's a great and extensive documentation that you can also do self-learning there.
Great advice.
Thanks a lot, Kartik, for mentioning the robot learning tutorial. So I'll just say very quickly, we tried to present a comprehensive tutorial that is basically mostly geared towards robot learning. So don't expect it to be like a complete introduction to the robotics field. But if you're interested in the more newer techniques related to machine learning and robotics, I think it's a great resource. Shout out to Francesco, who really worked very hard on it, our previous intern. So we would really love like to get everybody's opinion on it. And just to mention one thing, that we are always iterating on it, and we plan to have a new chapter for Groot next.
Fantastic.
That's awesome. That was something to request, but you said
Yeah,
it
no,
already.
we're working on it for sure.
Related question on Groot. We've got a question from LinkedIn. How to combine synthetic data from Isaac Sim and real world data to train Isaac Groot?
Yuliang, how about you
Yes.
take up this question?
Yeah, so there's a technique called co-training. So one thing that we normally do is to use synthetic data and also real world data to do like one-to-one co-training, and we can see a better performance, better performance, especially more motion generalization and smoothness. So this is something that we normally do internally in our research. I'm not too sure about how is this possible with the LeRobot API? Yeah, maybe Steven or Michael
Steven,
can
you
talk
probably know, but you've just introduced ways to merge data sets and combine data sets and edit them. So yeah, go ahead.
Exactly.
Okay.
Yeah, maybe I'm gonna leave Michelle going into much details, but essentially we have tools to merge data sets as long as they have the same features. So then from the user perspective, you will record your simulation, you will record your real data, and then you merge both of the data sets using these tools, which are recently available in the latest version of LiBERO, and then you will be good to go to train.
Yeah, so to add on about this, we will release N1.6 2 weeks from now, and we will have more customization of co-training. For example, users might want to do like a 1-to-1 ratio, or maybe a 0.8 to 0.2 ratio, or this different kind of sampling ratio with each, so you can have more customization for certain process. So the TLDR is the robot is a good, very nice place to start. But if you want like more advanced version with maybe less guidance, less documentation, certain things might break. Yeah, use the official Isaac Group version. But use the LiBERO version if you just want to get things started and then do different ablation of different kind of policies. Yeah.
Very cool. Okay, we've got a question here. Let me see. So a lot of excitement in the world about DGX Spark. So this person is asking, can they use Spark for training, or do you need H100?
And we've did it. It just takes quite longer, but it can definitely be done. You've trained the same process I just showed. We've done it on Spark.
Amazing. That's good news for all the Spark lovers out there. Here's a question from a regular viewer. She's a great member of the community. What is the best policy to train ROARM M3 Pro ARM? Anyone familiar with this one?
The policy, or more like the ARM, how you say, there's no like a policy that is best fit for a certain hardware. It is mostly, I would say, take it from the other perspective, in which you think about your task, and from your task, maybe you think about the policy that you want to train for that task.
Okay.
The hardware, most of the times, it is orthogonal, as long as the policy supports different embodiments.
Okay, that's great. That's super helpful. I'm sure going to help other people too. Got a good question coming from YouTube. What do you guys think about VLA and reinforcement learning? How is the sim to real performance in your experience?
Yeah, I can talk about VLA plus RL. And yeah, so to be honest, I feel that that's a very exciting route to go on. VLA plus RL, there's quite a lot of research, for example, physical intelligence on Pi 0.6 star. They show very promising sign of using RL. It's actually called iterative RL. You kind of do like dagger style way of doing one iteration, second iteration, third iteration thing. And also in here, we also show a PLD using a VLA and then plus RL, and then do residual RL based method to fine-tune fine-tune the VLA to make it more performant. So VLA plus RL is a very promising direction, and maybe Leo can talk about sim-to-real performance. Yep.
I'm not sure I'm the person to testify on sim-to-real performance. This is a little bit more for you.
Oh, I thought you.
I can say that it's. I
so
tried,
funny.
and I can say it's difficult. I have similar ideas, but essentially, you need to get your data in simulation as close as possible to what you get in the real life. This is
actually the hardest part is actually to sys-ID the simulation simulation environment and the real environment to make it as close as possible. So the sys-ID is actually the hardest. So that's why after the initial process of getting the asset right, and sim-to-real, once you get that particular matching actually works pretty well, you can just bootstrap it very easily with simulation. And this has been shown in like G1 because G1 people just do like very good sys-ID on the G1 robot itself. And then so you can see so many cool demos on people training G1 on Isaac Lab, and then just do like very similar sim-to-real on real world, and then do like fancy dance move. So I think we need to have a better way to do sim-to-real, a better domain randomization, better way of making the policy more robust to like this kind of perturbations in different kind of modeling, system model. Yeah.
Well, thank you for that. Okay, we've got a couple.
Point on
yes, Michelle.
Possible. Yeah, I mean, I'm very glad that people actually asked about reinforcement learning, because when I joined LeRobot, basically my main task was to actually integrate the RL stack in LeRobot. So in LeRobot, we have a real-world reinforcement learning stack. So the main method that we first decided to implement is called like human-in-the-loop sample-efficient reinforcement learning. And the main idea is to basically combine sample-efficient reinforcement learning algorithm, because when you're doing learning from interactions in the real world, you don't have the privilege of collecting like millions of data samples. So you want to be very sample efficient in your learning, but at the same time you want the human feedback, because it will also help you be more sample efficient and learn faster and learn corrective actions. So the only thing about that stack is it doesn't really make sense to learn everything from scratch. So when I say learn from scratch, is that you're going to start by your robot basically doing random actions, and you're going to try to guide it towards the actions that give you the best return, the best reward, which is basically means completing your task. So we are now currently working on developing this stack to incorporate foundation models or VLAs, basically, so that you can be able to fine-tune parts of these VLAs. And it really comes from the philosophy of at some point collecting more data is not going to be the solution. You're going to reach situations that your model, no matter how big and how much it's trained, it's going to fail. And the solution cannot be like, we're just going to need more data. So at some point you want to be able to learn from your experience. You want to be able to adapt your model. So of course, we're not the only ones working on that, but this has been like quite a community-driven project. So the community has really helped us, and it really highlights the power of open source, is that it's a very complex project with many elements, but we didn't have to do it alone, even though we were like 2 people working on it, but we had like the help of 4 to 5 really cracked guys, just because they're passionate about the project. So I would really also encourage people like to check out the RL stack in LeRobot, because we're really working, like pushing hard for it next year.
Very cool. Well, that's awesome. Lots of cool things to look forward to. All right, we got a few more minutes. I want to see if we could take one question. So I'm going to ask my panelists, actually, take a look at the start questions. You should see them. If there's one in there that really grabs you, that I think would help a lot of people, why don't you just say it out loud there if you can see it. If you can't see it, let me know. While we are waiting for our panelists to review these start questions, I want to give a big shout out to Amelia, who will be joining us a few minutes to go over the news after I let our nice guests go on with their evenings. And I want to thank you all in the crowd for submitting such great questions and comments throughout this live stream. Okay, so here we go. Here's a good question from Stephen. Stephen, you win. You're the first one to post the question. So do you see ACT improving with better sim, noise, and domain randomization, or is Groot's architecture inherently better suited for sim to real transfer. That's a good one. Where'd you get that from? I don't even see that. Was that in the regular chat?
I mean, yeah.
You just made it up. Did you make it up? Is that your own?
No, it is from Kyla Blackwell, I believe.
Okay,
from LinkedIn.
cool. I'll see if I. Oh, I see
Yeah,
it
I
here.
think it's a good question. Not
Here we
because I
go.
know the answer, but because I'm with the right experts that can
All right,
really
that's
cheat up
perfect. That's
and
what we're
get it
looking
to you,
for.
right?
Okay, so who wants to take this one? I put it up on the screen.
Actually, I don't have the answer for this.
Steven, I was counting on you.
Yeah, but I would think that AC in general VLA is better in synchronous transfer VLA. It can be like pi zero VLA or group VLA in general because to add on like what Michael is talking about, it's a matter of the art of leveraging prior. It's the same of RL or BC. If you just train everything from scratch, ACT is trained from scratch. You are not leveraging prior well. So it's the art of using prior. It can be a VLM prior. It can be world model prior. Yeah, just leveraging from prior, and your policy will be robust.
All
Yeah,
right,
it's like ACT is very brittle, right? Yeah, you need some baseline.
Yes.
You need some baseline
Yeah.
knowledge and experience that is in the back of the model, right?
Yeah, everything is trained from scratch. It's so brittle. Yeah, you need prior.
You know, I'm going to take this other question too because you know, Rishabh, you might have good feedback on this one coming from YouTube. Obviously, we talk about OpenUSD a lot on these live streams. Is having a good understanding of OpenUSD or the learning path we have for OpenUSD, which is again self-paced courses you can take, is that a prerequisite for understanding Isaac Sim and robotics? You think, Rishabh?
I think it's a good starting point because like we have the robotics fundamental learning path, which is like a deeper dive into what you can do with robots inside IsaacSim. But once you start to become a little bit of an advanced user where you want to maybe understand meshes, you want to understand stages, you want to understand layers and all those terminologies, that actually realms more into the OpenUSD world. So I would say as a beginner, maybe you could directly start with the robotics fundamental learning path. But as you start to get a little more into the weeds, you would need a better understanding of OpenUSD as well to find your way. So hope that
And
helps.
there is actually an OpenUSD certification, which launched not too long ago, and you can take them online, and you have to pay a little fee because it requires some moderation. But if you are attending a GTC in the future, there is an opportunity to take a free certification exam for OpenUSD at our GTC conferences. Next one's coming up in March, actually, in San Jose. So that's another reason to go to GTC. All right, you know, this person actually posted this on a couple of different platforms, so they're watching us on multiple channels. So I'm going to go ahead and show this on the screen. This is more of a hardware question, but let me see if we can answer this question for this very anxious user. For a robot, is there a small NVIDIA chip that can handle everything instead of adding a laptop? I wanted something cheap that can do it all. My prototype is still connected to a laptop. I mean, Brev is probably what this person's looking for, but what does everybody think?
I think it's a little open-ended, right? Sorry, Karthik, go ahead.
No, I think Brev would be like a really good option. And I would let Rishabh share his thoughts.
I think if he's saying small NVIDIA chip, like the first thing came to my mind was Jetson. So I don't really know what sort of task it's being used for, like what sort of compute the laptop is running. But if it's relatively lighter weight models, then you can get Jetson or Nano Spark, maybe. Yeah.
Spark, yeah.
So, yeah, there are options you can certainly take a look. And if it's heavyweight compute, then like Karthik suggested, maybe Brev is something they could look into. So it really depends in terms of what the task is.
I think also maybe Thor is a good option, just because you know, the raw power that you get out of it. I think it is a
exactly.
good.
But I really,
and the entire series.
I really think the Spark, and I'll tell you why. I think the difference between Thor, which is amazing, right, to Spark is that in Spark you can also run simulations. You can also do Isaac Sim and Isaac Lab, which you cannot do in Thor. So if you try to have some one-stop shop, you know, that is not a laptop, but it's on your desk, on your table, then I think that's the Spark at this point in time.
Well, that's great. You know, these are types of questions that are just awesome to discuss also on a Discord server. So hop on over to the Discord server for Hugging Face. We also have a great community on the Omniverse Discord server, and I think the OpenUSD study group is kicking off in 10 minutes. I'm sorry, the Isaac Sim, Isaac Lab study group is kicking off in 10 minutes if you're watching this live. I can't thank the guests enough for coming today. This has been such a valuable session, I think, for many. We have hundreds of people watching right live. So really, a big thanks to all the people watching. So many great comments and questions throughout. If we didn't get to your question, the conversation does not stop here. As I mentioned, go to the GitHub, go to the Discord server. Hugging Face is an amazing community. I hope that we follow some lessons from Hugging Face, and it shows on the Omniverse side of things, because we definitely look up to Hugging Face as just a great, a great team, a great community, and so excited about the work you're doing and the work we're doing together and the work you're doing with others. I think open source is just exciting so many people, and we went over all this stuff, but the barrier, the accessibility, these hackathons, there's so much action happening over the world on this stuff. So thank you all for presenting such a great layout for not only now, but what's happening in the future. Let's close this with any closing thoughts that our panelists might have on what they want their key takeaway to be, if you're going to remember one thing from this live stream. We're going to start with Lior, who looks like he's pensive in thought, and he's got something right on the tip of his tongue. So Lior, you just had that look on your face.
Oh man!
So you got first chop on the mic.
No, I mean, I think the key takeaway is just to stay tuned to all our channels, to what we're releasing, because we just keep, we and Hugging Face team keep releasing stuff that are, on the cutting edge of things. And I think the best thing is to try and experiment. Everybody that is there sitting on the fence, just, throw yourself in the water and try, experiment.
Yeah, those are great words. Very wise. Rishab.
I think it's going to be very similar to what Leo said. Like the technologies and all the pieces are so cool, but I think like the best way to get started is getting hands-on. So just pick up anything which you find interesting and start building. I think that's how you're going to learn the most. So
nice.
That's my 2 cents.
Yeah, no, that's good. And on that note, we also have a show and tell channel on our Discord server. I'm sure Shocking Face also has something on theirs. I love that channel. I love seeing what people are working on. So if you're doing something, you want to show it off, try to put it on LinkedIn if you're ready. But if not, you can show works in progress on Discord, and we'll be supportive there. Michelle, what do you think? What's a good takeaway from here?
I think as a general takeaway, whether it's about robotics or not, I would say I really think that people need to push more for open source, and we really appreciate the effort that NVIDIA does, because I think you guys have one of the top, if not the top number of open source models on the hub. So I think it just has been very inspiring to see the robot community just grow so rapidly, just because you are taking a technology that is often thought of as something that is hidden, that is basically only for private companies and labs, but making it accessible to everyone. So I would just give a shout out to just everyone that wants to contribute to open source, and I would really motivate you guys, obviously, if you're interested in robotics, to check out the work we're doing at LeRobot. And I really want to thank you guys for having us today.
Oh, thank you. Those are great parting words also. Kartik, what do you think?
Yeah, I mean, I would be looking forward to the contributions from the community, and we just started it, and then I would encourage the community to contribute there, improve our models, improve the ecosystem, and it's always the open source community that pushes the boundaries, and it is taking the big leap in the ecosystem there. So really looking forward to everyone's contribution there.
Stephen, I can't wait for yours. That was good, Kartik. Let's see if Stephen can top that.
Yeah. So I actually have two.
Oh, here we go.
That is for everyone watching the stream. So let me see. I think the first takeaway of this live stream is I just wanted to shout out how practical Brev is. If you are being bottlenecked by resources, by GPU resources, then definitely take a look on Brev, because that helps us internally and is also going to help the community out there. And then the second takeaway, it is let's see LeRobot as this one-stop shop for robotic learning. So if you're interested into getting started with robotic learning, robotics, open source, then check it out.
That's great. And Elaine, you're up the latest for this live stream, coming in from Singapore. So you definitely have the last word.
Yes. First, I'm sleepy. But anyway, I'm very interested in robot learning, and I feel that everyone in this panel actually do so, and also the live audience here. And one thing that I feel is we are in a very early stage of robot learning, right? Things are not work perfectly well. Things might break. But there are a lot of promising signs of using seeing all this wow robots actually work in the wild, and then eventually we will see home robot just serving us breakfast or even like help us with laundry. So I feel that because we are such in an early stage, it's better for us everyone to collaborate, and the best way to collaborate is open source, right? Everyone just throw what they are experimenting in the web or in their own research, and it's like academia. You just throw everything on the just share all our knowledges and also what the code, and people can just be a critic on like, oh, you are not doing this right, or just if things are doing great, just adapt it and then continue with the work. Like what ACT, division policy, the robot, everything all good. Yeah. So yeah, this is a very fun community effort, and hope to see more of it.
Yeah, I think so too. I have to double down on that. I see such a supportive community in the robotic developer community, so I love it. I want to thank again all of our guests for coming today. I'm going to let you guys go so you can go on with your night and let Yulin go to sleep. Thank you so much for joining and such a great presentation, Stephen, on your great work, and Michelle. Really, really thankful for both of you guys joining us today. And of course, my NVIDIA colleagues, can't thank you enough as well. Rishab, always great to have you on these live streams and especially the robotics office hours. And thank you for all the regular viewers and the new viewers out there. It's been a pleasure and honor. Hang out a few minutes. I'm going to bring our producer up for the first time. We're going to go over some news slides. And for all the other presenters, you can drop by hitting that little red arrow on the bottom and let us know when you want to come back.
Okay, thank you.
Thank you so much.
Thanks, everybody.
Bye-bye. Thanks, everyone.
Bye-bye.
Bye.
Thank you.
And now I am so excited. Rishab, you're totally welcome to hang out because I'm so excited. If you have to go, don't worry, you can go. But very excited to bring our producer here, who is the better half of the community team, as I always say, the much smarter half. Amelia is the one who really is instrumental in all of our live streams in terms of the planning, the coordination, bringing on the right guests, making sure the topics, we have all information presented. She's obviously a warrior in the chat, helping with all the links throughout every live stream. Amelia, thank you so much for joining us on camera for the first time.
Oh, anytime. My pleasure. I need to take a screenshot of this so I could show Mike Wagner and John Mitchell that I did show up in the screen.
Yeah, absolutely.
It's their loss for not showing up at this.
There's, I think for people probably know this already who are watching, but there's a lot of coordination and logistics that has to go into planning these live streams. We would not have such great success without your great help. And also the great support of the NVIDIA teammates like Rishab here, who make themselves available, because it's one thing to kind of set everything up correctly, but you need to have the experts on here to be able to answer the questions and really guide our developers. So Rishab, thank you and your team. These robotics office hours, I think, are really, really golden for a lot of developers we can see in the chat. So thank you for your help in them as well.
Thanks, Edmar and Amelia. I think I'm just so glad to be a part of all of this. It's always fun to understand how the community is using our products and how we can help them build better. So very excited to be a part of that whole process, and welcome, Amelia.
Yeah.
First time just seeing you on the live stream. So
I do want to add is that I started this new little question Q&A function on YouTube. So if you guys have any feedback on how we can make these live streams better, feel free to click on that and just drop your feedback there, as well as topics that you guys want us to cover. We're always looking for interesting topics or things that you want to learn a little bit more about. Drop them in the Q&A, and we'll definitely try to find a way to pull those topics into our office hours.
That's a great idea, great suggestion. Lots of great excitement in the chat from seeing Amelia here. So we've got some news slides here that, thanks to our great colleague Samantha, has put these together. So a lot of stuff has been happening in the news lately. It's hard to keep on top, so we try to put some of the things we really definitely think you don't want to miss in these news slides. Starting with Newton in action. Some awesome Newton demos came out during GTC DC, and we're also planning some exciting stuff for GTC San Jose in March. We hope that you all check out our recent Newton demo with Disney's BDX droid, which is one of the most exciting things that people have seen on stage with Jensen. Check out that QR code for more information there. Really, really exciting stuff happening with Disney all around. I think the next slide we have goes into the Walt Disney Imagineering. This has been made the rounds. I actually saw this on TV yesterday. I think when I was watching one of the news shows, this was called out. The Olaf, which many people will know from Frozen, and me having a 12-year-old daughter, I definitely know Olaf very well in our household. But there's been a great research and development that's gone on to a robotic Olaf. Super exciting. This video, I think the QR code will bring you to the video itself. It's a great video. I highly recommend. We were thinking about playing it, but it's kind of long. So definitely check out this video. But it's basically Walt Disney has been working on a robotics version of Olaf and just revealed it, and you'll be able to see it in full action in this video.
Yes.
And from BDX droids to Olaf, you can see how characters come to life with robotic technologies. The Disney robot team is really fantastic. They're making it possible using open source Newton and NVIDIA Isaac Sim for training, and powered by NVIDIA Jetson, which I just mentioned a few minutes ago. So watch the latest with Jensen and Walt Disney Imagineering team, Bruce Vaughn, who you see right there on the screen. This is a really great video. Amelia, you saw it earlier, right?
Yeah, it is. And definitely check it out. Olaf will be featured at 2 Disney locations, so Disneyland Paris, as well as Disneyland Hong Kong. So any of the ones that have, is it Arendelle? Is that the place where Frozen is set? But it'll be featured there. And I think it's supposed to like wander around the park.
Cool.
So it's really cute. So yeah,
that's awesome. It looks really good, super high quality. I'm and it's not something I would have pictured as being a perfect fit for robot, but it actually really is. You got to hand it to the Disney team, such a creative and talented technical team. And speaking of Frozen and the holidays, make your robot's holiday wish come true. We have a great discount happening actually, as we're all getting ready for the holidays. We are starting early. Make your robot wish come true with the power of NVIDIA Jetson. Our select robotics developer kits are now available with limited time discounts. This is pretty exciting. It's perfect for launching your next big project. The discount, it goes through January 11th, so you have some time. The only caveat here is that the discount's only available for United States developers. So that's the one thing that's unfortunate, but that's just that's the way it is. And but I hope that your United States developers can take advantage of it, because it's pretty nice nice discount. You can check out that QR code for more information. We also have a robotics learning series, from simulation to reality. This is a webinar taking place on Tuesday, December 2nd at 9 a.m. Pacific. It's an introduction to physical AI and robotics on NVIDIA. With these webinars, registration is required, but it's free. No big pain there. Just register, secure your space to engage in the webinar, and there's always great question and answer support at these webinars also. That QR code will bring you.
This is a 4-part series. So this is
4 parts.
Yes, this is a 4-part series that's going to happen throughout December. So registration should get you access to all the streams. So check it out. Yeah, it should be an exciting one.
That's awesome. Yeah, I think these webinars, so the experts will be there, and there's good chat, and you can ask your questions. So 4 parts. So you'll definitely become an expert by the time you're done with that. Okay, and I think we also have some insider tips for if you're at an educational university, school. Well, I guess if you're at a school university, hopefully it is educational. But if you're at one of those places, you can get some tips on how to make the most of your application for NVIDIA's academic grant program. This is a great webinar. I think our colleague Max had shared information on it on LinkedIn. I reshared it there. But you can use that QR code to find out how to make the most, get the greatest chances of your application getting through. I hope universities out there take full advantage of the academic grant program. There's no risk in applying, right? Only good things can happen. So hopefully that webinar will help people get it right the first time. But absolutely, we have actually education channel on our Discord server if you want to chat with other university people there, and or us on it too. And of course, we have our community resources. Amelia, I always go through the slides. Let's hear what you have to say about each of these links.
Definitely check out our ad events. I update it on a weekly basis with events that are happening in person and virtual as well. So what you'll notice is that I'll indicate like the region and typically it'll be like whether it's in person or virtual. So check those out. So it's not just purely all live streams. It's inclusive of everything that's happening around the community. So if you have a event that you would like us to promote, like a community-driven event, please let us know. Send me and Edmar a Discord message and say, hey, I want to add this to the calendar. We'll definitely add it to the calendar and let everybody know that like what's happening in your area. Forums where you go get your questions answers. For robotics specifically, I would go to GitHub. So Isaac Sim and Isaac Lab both have their GitHubs. Please go there. The Isaac Sim forum is still around. You can feel free to do that, but my recommendation is just we want everybody to go to GitHubs because it's easy for us to track and make sure that you get your questions answered. Discord is where we hang out, or where all the community hang out. You'll see a lot of the folks in the chat today, like Dylan. I think Tom. I think his alien is Tom. There's a few of them. I think like Siren, who's Scott Dempsey. Like everybody, most of these folks are hanging out on Discord. They're helping out the community. If you have questions, you can feel free to tag one of those guys too. They'll definitely help you out, as well as Edmar, and you'll see Richard 3D, who is Richard Yarlett, who's part of the TME team as well. He's on there. So if you have any questions, feel free to tag those guys, and we'll do what we can to support you. And then and last but not least is an ambassador program. So we have this great ambassador program, which a few of the folks in the chat are also part of, like Siren and Scott Dempsey and Dylan. It's a good opportunity for us to we want to celebrate and highlight all of our community members, and this is a great way for us to do that. These are people that thank you. These are people that are like movers and shakers in the community. They're helping people out on Discord. They have speaking engagements at different shows, and from time to time they show up on live stream. So if you're interested in becoming an ambassador, like Edmar, I believe that QR code takes you to the page where there is a link where you can email us. And
we'll send you a questionnaire. Yeah. So, you have a nice questionnaire so you can share your details on your work, what you're an expert on. You do not need to be an expert on all of Omniverse. That's impossible. Yeah. I'm not even sure if Rishab is an expert on everything in Omniverse. It's such a huge ecosystem and platform. But if you're a specialist in one area, for example, in Rishab's case, like Isaac Sim, or Isaac Lab, or any one of the areas, we would love to kind of highlight your work and know more about you and celebrate. So let us know. We're always looking to add more people, especially in other parts of the world. We have great ambassadors in the United States and Europe. Scott Dempsey is from the great land of Scotland, and love to find other areas of the world where we're missing some people to represent. There's a good compliment right here, Rishab. From Scott Dempsey, aka Sirens. Rishab is awesome. He is too. And you're not left out of this, Amelia. Like he's got. We love you too, Amelia. There you go.
I do want to add though, Edmar, like if there's anyone out there that has been recently like OpenUSD certified, please reach out and let us know. We will love to celebrate you. Like we know it's not easy to pass, so we want to definitely like promote and celebrate your achievement. So definitely reach out to us, or like even post on LinkedIn or on X and just tag us, or tag NVIDIA Omniverse or NVIDIA Robotics, and let us know.
Yes, and if you're missing these links because you're on your phone, we got to see a comment from Romeo on LinkedIn. Just feel free to shoot me an email. We will update the descriptions of the YouTube video, so you can go to the YouTube description and you'll find other links there. But you can always feel free to reach out. You can hit me on LinkedIn. Just search for Edmar. Actually, just go to edmar.net. It'll bring you right to my LinkedIn page. Thank you so much for joining. Amelia, what a fantastic debut. Came out smashing. I look forward to the next live stream with you. Rishab, always a really good honor to have you on these robotics office hours and any other Isaac simulated live stream that comes up. Thank you for joining us today. And I wish everybody out there celebrating Thanksgiving, if you're from the United States or elsewhere in the world, have a great rest of the week. We'll see you soon. You can continue to chat on Discord. As I mentioned, the Isaac Sim and Isaac Lab study group is in progress right now if you're watching live. Yes. With that, I'll say have a great rest of the day, everybody. Thank you.
Happy Thanksgiving.
Thank you so much.
Bye-bye.
Bye.